About 65 million years ago, a small asteroid more than 10 kilometers wide hurtled toward Earth at an astonishing speed of over 70,000 kilometers per hour. Its trajectory pointed straight at what is now the Yucatán Peninsula. Just before striking the shallow waters of the Gulf of Mexico, the asteroid triggered colossal tsunamis and ignited vast sheets of fire across the region. Fiery fragments rained down from the sky as the disaster rapidly escalated. This enormous object tore through the atmosphere with unstoppable force. For typical meteorites, the atmosphere provides enough resistance to slow them down and burn them up before they reach the ground. But this mountain-sized body behaved like a massive boulder plunging into still water. It pierced the entire atmosphere in just 3 seconds. As it crossed over Central America, the resulting sonic boom was deafening, and creatures on distant continents would have felt the shock in the air. On the ground, dinosaurs panicked and scattered, unaware of the cataclysm about to unfold. Animals near the impact site had no time to react. They were vaporized instantly by intense heat. Studies suggest that in this event, except for sea turtles and crocodiles, all four-legged animals over 25 kilograms perished. The asteroid fell so quickly that the air ahead of it could not escape. Instead, the air was violently compressed and heated to thousands of degrees Celsius. Before the asteroid even struck, the superheated air had already vaporized the shallow seas around the Yucatan. Moments later, the asteroid slammed into the crust, releasing unimaginable energy. The pressure at the point of impact was so extreme that soil and rock briefly flowed like liquid. A bottomless crater opened as the crust collapsed downward. The ground then rebounded upward, creating a double wave effect, similar to a stone hitting water. The first shockwave expanded in all directions, hurling debris 32 kilometers into the sky. At the same time, the surface beneath the impact rose violently, shooting upward at 1,600 kilometers per hour, briefly forming a peak higher than Mount Everest. This mountain of rock and debris lasted only a few minutes before collapsing in a series of explosions, leaving behind a circular ridge that remains a hallmark of the impact crater. Meanwhile, the asteroid's kinetic energy converted instantly into extreme heat, melting and vaporizing rock, and even breaking some materials apart into plasma. The total energy released reached 1.3 times 10 joules more than a billion Hiroshima-scale nuclear bombs. A blazing thermal blast swept across the region, and the shockwave expanded outward at 1,600 kilometers per hour, reducing everything near the impact site to ash. If a similar-sized asteroid struck the same spot today, the entire state of Texas would be instantly vaporized. People in New York would be deafened by the sonic boom, and windows in Buenos Aires would shatter from the distant shock. Earth itself felt as though struck by a cosmic hammer. Seismic waves raced through the crust at 4 kilometers per second, triggering global earthquakes. Even on the opposite side of the planet, the ground would begin trembling just 30 minutes later. Meanwhile, tsunamis hundreds of meters high swept across the Gulf of Mexico. Within an hour, they crashed into the coasts of North America, pushing seawater far inland and overwhelming shorelines. 6 hours later, 600-meter-high waves struck Europe, Africa, and the Mediterranean. Within 15 hours, coastlines around the world were devastated. Yet, the catastrophe was far from over. The explosion ejected more than 25 trillion tons of rock into space. Some fragments escaped Earth's gravity entirely, scattering throughout the solar system and even reaching the moon. But most of the debris fell back to Earth as a global meteor storm. As these fragments re-entered the atmosphere, they heated to incandescence and ignited forests and grasslands across the planet. Night skies turned into burning horizons. Temperatures soared rapidly. Then dust and smoke choked the atmosphere, blocking sunlight. Earth descended into prolonged darkness. Temperatures plummeted. Ecosystems collapsed. A mass extinction swept across the globe. This event marked the end of the age of dinosaurs and cleared the way for the rise of mammals. Had the asteroid never arrived, dinosaurs might still dominate Earth today and humans might never have appeared. Among the debris were glassy fragments known as tektites, some the size of buses. though most no larger than marbles. These tektites did not need to strike dinosaurs directly. The heat they released during re-entry was deadly enough. Their intense thermal radiation ignited global wildfires, consuming forests on every continent. The total heat released by the falling debris was enough to turn Earth into a tremendous oven, burning almost all vegetation. The global firestorm didn't last long, because the impact also vaporized and lifted the equivalent of more than 150 stadiums worth of crude oil into the stratosphere. This oil condensed into a thick layer of black soot. Unlike sulfur particles or smoke from wildfires, this soot remained above the clouds and did not fall with the rain. This created an even more severe problem. The soot blocked over 90% of incoming sunlight for at least 2 to 3 years. After the extreme heat caused by the falling debris, the planet plunged into a long, intense global winter. Using supercomputer simulations, researchers analyzed the possible origin of this asteroid. Two astronomers, Avi Loeb and Amir Siraj, proposed that the object may have originated from the Oort cloud at the solar system's outermost AGI, vast region filled with comets and icy debris. They suggest it may once have been part of a much larger comet. A gravitational interaction with Jupiter likely deflected it toward the Sun. As it approached the Sun, intense heating caused it to fracture into multiple pieces. One of those fragments eventually entered Earth's orbit and delivered the catastrophic blow. Studies estimate that such impacts occur once every 250 million to 730 million years. In other words, the question is not whether it will happen again, but when. On December 11, 2021, NASA announced observations of a 330-meter-long asteroid named 4660, nearest passing Earth at 6.5 kilometers per second. Its closest distance was about 3.8 million kilometers. That may not sound close, but on a cosmic scale, even slight orbital shifts could send such a body toward Earth in the future. Astronomers are closely monitoring this potentially hazardous asteroid. They predict that on February 14, 2060, it will pass even closer, just 1.1 million kilometers from Earth. It's worth remembering that the meteor that exploded over Chelyabinsk, Russia, in 2013 was only 20 meters across, yet still caused major damage. Currently, humanity has no guaranteed method to stop a large incoming body. NASA is testing a mission called the Double Asteroid Redirection Test, or DART, to determine whether a spacecraft can autonomously navigate and collide with an asteroid to alter its orbit through kinetic impact. Its target is Dimorphos, a small moon orbiting the larger asteroid Didymos. The spacecraft was expected to reach the target in late 2022, when the Didymos system was about 11 million kilometers from Earth. Scientists predicted that the impact would change Dimorphos's speed by less than 1%. To stop a 10-kilometer-wide asteroid traveling over 72 kilometers per second, kinetic impact alone would not be enough. Humanity might eventually need to consider nuclear intervention. If this journey through Earth's darkest day stirred something in you, imagine what other cosmic secrets are still waiting to be uncovered. Every week, we dive deeper into the mysteries of our universe, its wonders, its dangers, and its untold stories. So, if you'd like to keep traveling with us through space and time, don't forget to like this video and subscribe to Interstellar Whispers. Share it with someone who loves the unknown as much as you do. And hit the bell icon so the next whisper from the cosmos finds you first.